Alright, so today we're going to be dealing with different types of angles. We've already done central angles, okay, but we'll talk about them some more, okay. But a central angle, what makes it an angle central is its vertex is at the center of the circle. For instance, right here, oops, let me fix that. Yeah. This angle right here, O is the center of the circle, and that is a angle right there, and so that angle ROP, angle ROP, that is a central angle, okay, where O is the center. So you can only have a central angle if you have a point that is representing the center of the circle, because that's where the vertex would be, okay. And remember that its intercepted arc, right here, arc RP, is the same. It has the same measure. In other words, if angle ROP equaled 110, let's just say I gave it an angle or degree measure, then the arc RP, remember the symbol from the other day? That's the arc symbol. Then the arc RP also equals 110 degrees. Okay. Now for the new types of things is an inscribed angle. All an inscribed angle is, it's an angle that its vertex is on the edge of a circle. Okay. For instance, if you look, I'm going to use blue, but right here where you have point Q right there, that angle that is being formed, the vertex is right on the edge of the circle. Well, that is an inscribed angle. Okay. And so that's what it is. It's an angle that has the vertex, and we'll go ahead and write that. The vertex is on the circle. And I'm sorry I don't have my stylus pen with me, so I'm using my finger. Where the central angle, the vertex is on the center. Okay. Well, its intercepted arc, okay, is still the same arc. This arc over here, RP, now I'm shading it blue, it's the same intercepted arc. Remember, the arc RP right here was equal to the same thing as the central angle. They were both 110. The difference is that in a inscribed angle, its intercepted arc is equal to half its measure. So if angle R, let me change colors. If angle R excuse me, I messed up. Let me start over. If I told you that angle RQP, the angle, the inscribed angle, if I told you that it equaled 55, okay, and then I asked you what its intercepted arc, which the intercepted arc is RP, well, it's twice, the arc is twice the inscribed angle, so just double it, and 55 times 2 would give you 110. Okay? So an inscribed angle is equal to half the measure of its intercepted arc. And that's what this next theorem is. Okay? It's the measure of an inscribed angle theorem. And it reads that the measure of an inscribed angle is 1/2 the measure of the intercepted arc. So just to kind of quickly review, here we have an inscribed angle. Right here where D is, that is the inscribed angle. I'm just going to put INS for inscribed, and then the angle symbol. That's my inscribed angle. Well, in blue, and I'll use marker this time, AB, that arc, that is the intercepted arc. Okay? And so angle A DC, or excuse me, ADB is equal to 1/2 whatever arc AB is. Okay? In other words, just to make sure we're clear, if I told you that angle ADB was 50 degrees, okay, well, 1/2 times, what would AB have to be? Well, it would have to be 100, right? Because half of 100 would be 50. So the arc is double the angle. Okay. Then we have another theorem here. It's the inscribed angles of a circle theorem. If two inscribed angles of a circle intersect the same arc, then the angles are congruent. Okay. Well, so I'm going to use blue for this angle here. There is the inscribed angle that has D as the vertex, and the arc is arc AB. That's the intercepted arc to that angle. Then I'm going to switch to black. Okay, black represents angle C. That's the inscribed angle, angle C. That is the second angle, but its intercepted arc, it's the same arc. It's AB. Well, both those arcs are going to be congruent, right? AB is congruent. Arc AB is congruent to arc AB. So since arc AB is congruent to AB, then those two angles must also be congruent. In other words, if I told you that arc AB, let's say I said it equals, I don't know, we'll just make up a number, 70 degrees. Well, the angle is half that size. So angle D is going to equal 35. And angle C is going to be 35. Okay? So let's try to tie this together. I'll do the first set of problems with you. Here they ask us to find the angle measure. Pay attention to your markings, because right here in A, they're asking you to find the measure of angle T. So what they want you to find, I'll switch to a marker, is this right here that I'm shading, that is the angle T. So they want us to find that angle. Well, first of all, what type of angle is it? Is the vertex acentral in the center, or is it on the side of the circle? Well, it's on the side of the circle, so that makes angle T an inscribed angle. Well, this arc right here, arc RS, that is the intercepted arc, and so the arc is 48, so the angle is half of that. What's half of 48? That's right, it's 24. So angle T equals 24. So now we're going to do B. They want us to find the measure of arc QR. So what they're wanting us to find is this measure of this arc right here. Well, there's a couple ways you can do this. It doesn't matter how you slice it. But one thing you can do is look at R. Isn't R an inscribed angle? Well, and this, I'm going to change colors, this is the intercepted arc. Well, but this red arc, the one that we're trying to find, and the blue arc, don't they make a semicircle? So when I combine the blue with the red, I get a semicircle, which is 180 degrees, right? Well, I can find the blue arc, right? Because it is opposite this 50-degree angle, and the arc is double that, right? So since the inscribed angle is 50, then the arc QT equals 100. And remember, this gold thing, or whatever color this is, the total has to be 180. Well, there's 100 in the blue arc, so what's left? 80. And so that's what's left, and so arc QR is 80 degrees. Okay? Just remember that your arc measure is double the angle, and your inscribed angle measure is half the arc. Okay, so let's move on. All right, I want you to do this top example on the front. They want you to find two things. They want you to find the arc RS, and so I'm going to color code that for you. RS, this is the arc that they're asking you to find. And then they also ask you to find angle STR. Well, STR is this angle right here, and that's the inscribed angle. Well, isn't this angle, the blue angle that I have shaded, isn't its intercepted arc this arc they want you to find? So that's going to help you. Well, I want to change the black. How about this angle right here? This that has U, the inscribed angle of U. Isn't this same arc the intercepted arc with that angle? Well, these two angles, the blue one and the black one, they're the same. They're intersecting the same arc. So doesn't that mean the angles are congruent? So that should help you. So go ahead and try to do this on your own. When you get finished, raise your hand and see if you can get this correctly. Also do number 3 as well. Okay? Alright, so now you should have gotten help with the sub. Okay. So now we'll go to monitoring progress. So I'm going to get you started on some of this. So they want us to find the measure of the red arc or angle. So whatever is the red measure, that's what they're wanting us to find. Okay. Well, look at this. They're wanting us to find the red measure is this object here that is shaded in black. So aren't they wanting me to find the inscribed angle, the angle that is HGF, that inscribed angle? That's what they're wanting us to find. Well, this arc right here that is 90, that's its intercepted arc. Well, the arc is twice the size. So what do I need to do to the angle to find the angle measure? That's right. Take 90, divide it by 2, and you would get that that angle is 45 degrees. Pretty easy, huh? Let's go on the next one. Here, the red stuff is the arc TV. So, this angle here that is 38, that's its intercepted angle. Well, the angle is half the size, so to figure out this arc, don't we do double 38? So, we go 38 times 2, and we find that the arc TV equals 76. Okay, so let's go ahead and go to number 3. I want you to do number 3, but I am going to give you a hint. Okay, this angle here, angle Y, and this here, angle X, those two inscribed angles, they are both intercepting this arc ZW. Well, remember what happens when two inscribed angles intercept the same arc? The angles are equal or congruent. So that should give you a hint on how to find angle ZXV. So you guys do number 3 on your own, and when you think you have the answer, raise your hand and the sub can check your work. Alright, a little additional information is inscribed polygons. Well, think about it. An inscribed angle in a circle just meant that the angle was on the edge of the circle, on the outside edge of the circle. Well, if you have all an inscribed polygon is some type of shape, whether it's a square, a pentagon, a hexagon, whatever, a triangle, each one of the vertices of that object is touching the circle, so each one of them is a inscribed angle. That's all that's going on here. Okay, and so a circle is circumscribed around the object. Okay, so if you look at this drawing right here, you can see you have a pentagon, and at each one of the vertices of this pentagon, see my black dots as I go around, okay, it's touching the circle, so it has 5 inscribed angles, right? And so it is circumscribed. Anytime they tell you that something is circumscribed, that just means that a circle is going around it. The object is inside the circle, but all the vertices of the object are touching the circle, making inscribed angles. Okay? The inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of a circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. Bottom line is this. AC here That is your diameter. Okay? So that means this arc here is 180 degrees. Well, isn't this arc opposite or the intercepted arc of angle B? Well, this arc is 180 degrees. The inscribed angle has to be half of that, so that would make angle B be what? 90. So that triangle there that's made is a right triangle. Okay? And it can work both ways. The next theorem is the inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay? And what they're talking about, make sure you understand that, for instance, angle F and angle D are opposite angles. And so since they're inscribed in a circle, that means that they have those two angles, angle F and angle D, have to be supplementary. What does supplementary mean? 180. Okay? And also, the other set of angles, angle E and angle G, they also have to be supplementary. They're opposite as well. So angle E and angle G are supplementary or add up to 180. Okay. So let's do example 4. I'm going to do both of them with you. Okay. First of all, isn't this the diameter right there? AB. So that means this is this arc is a semicircle. It's 180 degrees. Well, this angle here, where C is, okay, that's an inscribed angle, and it's equal to half of that. Well, if the arc equals 180, doesn't this angle here equal 90? So they want us to find x, right? So that 2x, whatever x it is, when you multiply it to 2, wouldn't you have to get 90? Doesn't that angle have to be 90? And so when I divide by 2, I get that x equals 45. Okay? Alright, on part B, I'm going to find y, you're going to find z. Well, we just did this. We learned that the opposite angles, these two angles here, y and 120, are supplementary. If I have a quadrilateral, the opposite angles are supplementary. So that means y and 120 have to add up to 180. Well, subtract 120, and y equals 60. So I just found what y equals. It equals 60 degrees. Okay? And now you find z. And then whenever you find what z is, then raise your hand and have the sub check your work. Okay? I'm going to do just one out of this section. You guys are going to do the other two. So I'm going to do number 5. You guys are going to do 4 and 6. And when you get finished with 4 and 6, raise your hand and have the substitute look at your answers or help you get unstuck. Okay, but on number 5 here, they want us to find x and y. And it doesn't matter where I start, but I have a quadrilateral, so I need to use the rule for a quadrilateral, which says that the opposite angles, in other words, y and 68, are supplementary. So y plus 68 has to add up to 180. That was ugly 80. Okay, so I'd subtract 68. Okay, and so I get y equals 180 minus 68 is 112. So that's what y equals. Well, now I'm going to find x, and it's the same thing. X and 82 are opposite angles, so x plus 82 equals 180. Why? Because they're supplementary. Subtract 82. Okay, and you get that x equals 98. So that is number 5. You guys do number 4 and number 6. When you're finished with 4 and 6, raise your hand. Let the sub come by and check it out. And then once you are finished with your notes, go ahead and begin the assignment that's attached. I believe there's only 9 problems, so it's not a long assignment. And then at the next class period, your notes and your assignment are both due. Okay? And have a good weekend.